Okay, so we are going to do the last example of our notes here. So it says, use the continuity test to determine whether the function is continuous. And so the only point that we need to check here, we need to check at x is equal to 5 because the left side of the piecewise function, x squared plus 1, is continuous. And the right side of the piecewise function, 6x minus 3, is also continuous. Therefore, the only point that it could be discontinuous is where the piecewise function comes together at 5. So we are going to evaluate using our continuity test to see if the piecewise function is continuous at 5. So let's go through the continuity test, which first says, does f of 5 exist? And the answer is yes. F of 5 is going to be 27. 6 times 5 minus 3. And I am plugging into the bottom equation, not the top equation, because that is where the function is defined. In other words, the top equation is all values of x less than 5. And so it's equal to 5 on the bottom equation, the linear equation, 6x minus 3. So f of 5 does exist. It's equal to 27. The next step in the continuity test is to check whether the limit exists. So part B, does the limit as x approaches 5 exist? And for this to be true, the left-hand limit and the right-hand limit have to be equal. And so you really need to show that when you are writing this out. So I'm going to check the left side, the limit as x approaches 5 from the left-hand side. And so I'm plugging into the parabola there. And 5 squared plus 1 gives me 26. And the limit on the right-hand side, I'm plugging into the linear function. And so we get 27 for that. And since the left-hand limit is 26 and the right-hand limit is 27, I know that the limit as x approaches 5 does not exist. And therefore, f of x is not continuous at x is equal to 5.